Right. So Spring is what we are looking at. Okay, we are taking a simple Hello World program and trying to understand the various features of Spring. Okay, and so as you can see, there's a Hello World program, right? And it's hard coded to display Hello World, right? But in future, if I have to change the content, I'll have to come again, change the code over here and display it straightforward. But rather than doing that, I can make it more dynamic by doing what? By giving a command line argument program, and I would expect the input from the user. And if nothing comes in, I would go for my default implementation, that's hello world. Right? This is how we code. This is what our intention is, that to make it loosely coupled, less coupling, if not tight coupling, loose coupling, and to make it as flexible as possible, so that in future if you have to make a change, okay, we don't have to change our legacy code. That's our objective. Okay, you getting it? This is what our approach is, and this is what we're going to be improving as we move ahead. ठीक है. Okay, outstanding problems. Now what happens is, I have a particular requirement. My requirement is what? Hello world program, displaying hello world. Okay? And as I told you, I have to change goodbye world. I have to change it, fine. But the source is very much restricted right now. The source of how my message comes to this program is very restricted, which is the command form, as you all can see. I want to make it more dynamic. I mean, I can take it from a web service, I can take it from another program, I can do remoting. I want facilities wherein I can have more interaction with this code rather than just the command form. So that is one area I have to improve. The way of getting this message, that is the message source. Other area I am trying to focus is the rendering. What is rendering? Right now I simply provide the input inside the println method, correct? And something happens and it's shown on the screen. What if I want to show some tags with it? What if I want to change the color of it? Right now I simply does a system.error. What if I want to do system.error, ERR? You show me red text. I can't do that right now. It's strict. Okay. So I'm going to be focusing on two areas. One is the rendering, okay, and the message source. The rendering logic should be logically separate code from the rest of the application. Same thing with the message provider logic. Okay, I'm going to be separating all these two things. Okay. Okay, to achieve this aspect, what I did is I have separated out the code, I've decoupled the code, okay, and created classes for that. I've created a class for the hello world message provider, right, whose sole responsibility is providing the message. Right, provider, it's going to be providing something. What is going to provide? The hello world. That's it. Now, right now, this method which has get message is doing nothing great by just simply returning hello world. Right. If I want in future, I want to change the methodology, I can do some changes over here and make it work. Here we have the standard out message renderer. Okay, we have the standard out message renderer, whose job is to render. Now, one thing that you need to understand: this rendering, this processing, it will not happen by itself, right? It is depending on something. It depends on the message. It will process, it will render, that's right. But it has to render something, right? So it is depending on something. So it is dependent on the provider. Correct? Isn't it? It is depending on the provider. Since it is dependent on the provider, I have to declare this as a field in my class. Field in my class. I'm declaring this as a field, right? I'm declaring hello world message provider space message provider. Okay? I'm declaring as a field because I'm depending on that. And eventually I have to call the setter method to set this thing also, right? This is the render logic. The rendering logic will actually do the rendering and display the content for me. As of now, I'm not doing anything great. I'm simply saying message provider dot get message. I'm going to get the actual message content that I want to show and do a system.println over here. In future, maybe I can change this println line to do something different, right? So this is the rendering logic. We saw the message source provider, hello world message provider, standard out message renderer. There's a third part of the code which is called as the launcher. Okay, where we write the business logic. It has to tie up everything together. So, which is called as the hello world decoupled. I get the instance of the standard out message renderer. I get the instance of the message provider, hello world message provider, right? And then simply I have to set the message provider inside the renderer. Because why? The provider is a dependency, right? And then we simply call the mr.render method, which will do the processing and display the content. Is this flow clear of what and how we have decoupled the code? The message provider, whose job is simply provide the message. The message renderer, whose job is to render the message, processing the message. and the code finally called as launcher, which will is responsible to get everything together and run it. In future, if I want to make some drastic changes, I'll change the instances over here. Let's say if I have goodbye world message provider, I'll remove this class from here, create a class called as goodbye world message provider, which will return some other text like goodbye maybe. Okay, and put it over here. So my existing classes are safe, because I'm sure there might be some other classes depending on hello world message provider. I simply can't keep on changing everything, because there are other people also depending on that. That's a bad practice. Worst case scenario, what you can do is you can extend that class maybe and use that extended class for your purposes. But then again, this is what we are looking at right now. Now we are trying to decouple code as we move on. Clear till here?
So the job of the renderer is just to change the display of the message.
Yeah, it's processing. It's how you want to display the content right now. That's our job.
It's only dealing with the appearance of the text.
You can say that. Or more to do how we are showing the content. More to do with that. Any questions? Any queries? Clear? Okay. Now I'm going to go a bit ahead. I did tell you that today I'm displaying hello world message provider, which is reading me hello world. Tomorrow I want to change it to goodbye world. And as I know, I don't want to change the existing code and all that stuff. So probably what I'll do, I'll bring in another class, goodbye world message provider. But in doing that, what happens? I somehow get my renderer affected. The standard message renderer, right? I have to make a change that, right? Why? Because it depends on the provider. Initially, it depended on the hello world message provider. Now it will depend on the goodbye world message provider. So I have to go, I have to change this thing to goodbye world message provider, space message provider equal to null. Which once again is something conflicting with my principles. My principle is that when I make a change in some area, it should not affect the other areas. I'm changing the renderer area, but I should not go and affect the, making the provider area. I'm making a change inside the provider area. But somehow I'm affecting the renderer part, which is a bad practice. Isn't it? It's not a good thing to do. So this is an outstanding problem. You all agree? Yes? How do we deal with this? A better way to deal with this is, rather than me sending concrete instances over here, or rather giving concrete instances, it would be nicer if I could use an interface, right? And via the setter-getter mechanism, I could supply the interface reference. That interface reference can hold anything. It can be hello world, goodbye world, or any other word. Comparing that, it's implementing the interface, right? So let's try that approach. What we do is, we'll have an interface called as message provider, okay, and the key method would be the get message. So any class who claims to be message provider, that can be hello world message provider or goodbye world message provider, should be overriding the get message method, right? It will be doing that. So that's the key method over here, right? This is the class which implements the message provider and gives the definition for that method, right? Since the problem which I face for provider over here, I'm sure I might face the same problem for render also, going ahead. Render also might be having some, maybe as a dependent on some other class, right? So that time also I'll have some issue. So I'll create an interface for that as well. I have a message renderer, and the render method is the one responsible for doing the rendering, right? Then we have the setter getter. Obviously, if someone claims to be a message renderer, it needs to have a mechanism to get and set the renderer, the provider, right? Okay. And obviously I have the class implementing the message renderer, right? And the render method will do the getting of the actual thing, message provider will get message. If it's null, I get a different kind of an output altogether. Is it clear so far? So now what has happened at this point of time, if you see, previously we had over here private hello world message provider space message provider equal to null, right? But now we have message provider over here. Only message provider, it's an abstract reference. So this message provider can be set over here. Okay, it can be hello world message provider, goodbye world message provider, that doesn't make any difference to it. It's generally taking a message provider, right? That's the approach of the interfaces. So now my launcher has changed to what? Now my launcher says message renderer, which is an interface reference, equal to new standard out message renderer. This is called as inheritance, right? We are all aware of that. Similarly, we go the same approach, we take the same approach for the provider, and we say message provider space mp equal to new hello world message provider, right? And then I simply say mr.set message provider mp. Now this mp over here, the definition of that mentioned over there, just takes a message provider. It doesn't say that it has to be hello world message provider or it has to be some specific kind of message provider. It simply takes a message provider. So I have achieved a better level of decoupling, isn't it? I have achieved a better level of decoupling wherein I am not giving the hardcode reference, right? So now my renderer is safe. I do not expect any change because of the provider over here. Everybody agrees with me? Hmm? Any questions so far? Try to understand the scenario one by one. Then otherwise, in going ahead, if you don't understand something there, you'll have to come back over here.
But the launcher part is still a bit rigid.
Exactly. Perfect. That's a good catch. So I was going to get to that only eventually. That since we did solve the renderer problem, my launcher is still getting affected. My launcher, as you can see over here, still has to get changed. Initially there was hello world message provider. Now there's going to be goodbye world message provider. So somehow I'm still affecting the other areas. That's right. So how do we do it? Well, I can't just keep creating classes and interfaces to deal with that. That would be a bad practice because somehow this class name will be going in. Somewhere the class name will go and then again the problem will appear. So what I can do is I can create a temporary property file kind of a thing, right? And I might, rather than putting this class name inside a class, okay, wherein I have to compile, process, deploy the WAR file, because obviously let's say this is a part of a web application. I get a WAR file, so I have to deploy the WAR file again and again. I can put that information in a property file. And the best way to deal with this scenario is creating a factory class of our own. A factory class. A factory class is nothing big. It's just a factory for creating beans. Nothing much. So let's look at a sample of that. See, this is the outstanding problem. That's as you mentioned. That even though we have achieved decoupling in our renderer class, but still the launcher class suffers from that problem. Because if I am changing to hello world message provider, goodbye world message provider, although I'm changing the provider, I still have to make a change over here. That's definitely a problem area. Correct? So how do I deal with this? I'm creating a factory class, a singleton factory class. What is singleton? Singleton means create only one instance all the time. Okay? That whose job is what? Whose job is to take the details from a property file. This is the property file. I've created a property file. Okay, that has a key value pair. What is the key? Renderer.class. Right? And the value is standard.message renderer. Provide.clause. And the value is hello world message provider. This is the property file. Let's see how I deal with it. Let's focus on this area. This is the constructor of the message support factory, which is our factory class. What are we doing? There's a class called as properties that deals with the dealing with the property files. So we create that first. We load the properties with the property file that we have created, msf.properties, via this line. Okay, the property file is loaded. Moving ahead, what we do is we further say props. This is the property reference. Dot get property renderer dot class. When I say get property renderer dot class, it will search the property file for a left hand side key. Right? It will search for a left and right side key, which happens to be this one. Right? And after it realizes that okay, this is renderer dot class, that's the value it will return back is this. So this thing will be saved over here. So now what we're getting is just getting the name, not the real instance, just the name. So this field will hold standard out message renderer value string. Similarly, properties dot get property provider dot class. This thing will return what? This thing will return a string hello world message provider, correct? And that string will go inside this field. Right? So there we have two fields now currently which are having the names that we want to work with. And what we did, we simply loaded from a property file. Moving ahead, we simply say class.forName. I'm sure you must have seen this in JDBC. Class.forName, we give the name, and further we say give me a new instance. After loading the class, I have to give the instance. So I'm saying dot new instance, and now this renderer and provider, which is actually message renderer and message provider references, get populated with the actual instances. So in this case, here, this field, which is a type of message renderer, will hold an instance of standard out message renderer, right? And this field over here, provider, this field, which is a type message provider, will hold the value of standard out message provider. Make sense? Yes? Any doubts? What are we doing? We are reading the details from a property file. Right? Reading from property file. So what happens now in this case? Things change, right? But not in my class. My class remains intact. My property file keeps on changing, which is very convenient. It's just like reading a database value. Okay? Okay. Having that done, and obviously this class has some setters and getters. Okay? And what I do is basically I call a method called as getInstance. This getInstance and this getInstance method is called the static method. Block will be run, and it will call the constructor. The constructor cannot be called externally because it is private. So every time I can only call only one class at a time. So my launcher now becomes what? My launcher now looks like this: message support factory dot get instance, okay, which will trigger everything over there. Dot get message renderer. this will give me the renderer reference. In our case, it is the standard out message renderer. Similarly, message support factory dot get instance dot get message provider. This field now will hold the message hello world message provider. Right? So, and eventually I have to set the things and call the render method to do the processing. So the focus over here is what? Now my launcher code is also perfectly decoupled. Now any changes that comes in, let's say in this case, say renderer also, renderer or provider, anything, any changes over there, my launcher is intact. As long as they are renderer and provider, it is intact. I come with a third form maybe in future, then I make a change. I might have to make a change over here with some other logic. But now I have decoupled. Now I can work with any kind of renderer. I can work with any kind of provider. Right? So today I'm working with hello world message provider. Tomorrow I work with goodbye world message provider. The only change I make is over here. Are you getting it? This is how we are decoupling the code. Any questions so far? Any queries? No? Okay. Now, making a factory class is very nice. It's a nice thing to do. But there are many things you have to deal with in a factory class, like exception handling, error handling, many scenarios to look into. So rather than we making something, we creating the wheel, it's let's take an existing factory class that we can use for a utility. We have a factory class called as default listable wheel factory class, which is the same factory class Spring uses. Okay, which is the same factory class as Spring uses. Okay. So we'll use that and let's see what changes do we have in our picture. Okay, now we are calling a method get bean factory, which will get me the factory class back. So in that, first of all, I'm getting the default listable bean factory is something which is already created. It is an existing class within the Spring jars. I'm not making it by myself. Okay, so first I create the factory. Further, there's another instance I'm creating, properties bean definition reader. This is also a part of the Spring jars. I'm not creating this. Okay, this guy's job is to read the beans in a better way. Okay. Now, how is this linked to this link? The factory, we are passing a reference of the factory over. So it keeps a link over there. Then I still need the properties. I have the properties. I load the properties. Okay, but that area, that area where we used to write get the name, properties or get property, then class.for name, all that stuff. Okay, now we won't be doing that. We have a existing method called as register bean definition that will do it for us. Okay, it understands that okay, if somebody is asking for that key, give them that value. That's the only change. Okay, and then the factory returns, and from the factory we say get bean renderer, get bean provider. Okay, slight optimization, not a very big deal. Slight optimization. We are using an existing factory class of the Spring. Okay, right? Mo, any questions? No. Okay. Okay. All right. Now, now I'm going to talk about Spring. Spring, as in Spring is it's the best part of Spring is that it focuses more on the business logic. Okay, it says that the redundant configuration changes. Okay, that is something you should not be doing as a developer. You are something to write project business logic. That's all you should be focusing on. So I know that whenever I talk about the renderer, I need the provider. Whenever I'm talking about the renderer, I need the provider. But obviously, because it is a dependency, but still I have to create it separately, set it as a inside the method. One other way of dealing with this scenario is what I make a constructor that takes a renderer. But then again, it's the same thing. I still have to create the instance and pass it as a reference. What if Spring was smart enough to understand this facility that I need the provider when I call the renderer? Wouldn't it be nice? That Spring would understand by itself that if I'm asking for a renderer, give me a provider. You're getting my approach, right? What I'm trying to achieve here, right? Let's see how that happens. Till here things are clear. Okay, what it is doing? It is basically instantiating an existing factory class. We have we have something called as properties bean definition reader, who is responsible to read the property file. Okay, right? That's where the magic happens actually. We'll see that now. Moving ahead, how we remove that dependency part thing. Okay, so this is something that we've seen. Now what happens? Now we talk of the real dependency injection. Prior to this change, we had render.class equal to standard.message renderer. Okay, provider.class equal to hello world message provider. Now what is the new change? Now pay close attention to this. Whenever I will say to that factory dot get bean renderer, okay, it will come here. Obviously, it is going to see that this is renderer. Give him the standard message renderer. At the same time, it will read that there is a renderer.message provider ref equal to provider code. What does this mean? This means, okay, now pay attention. Inside renderer, the dot operator means there is something inside that thing. inside renderer there is a message provider. Inside renderer there is a message provider. Okay, it's right over there. And there's a getter setter, right? So I'm gonna call the setter method for that message provider. I'm gonna call the setter method of that message provider. Now, as you know very well, I'm going to set something, I have to supply something. It's not going to return me a blank thing. It has to give something, so it will set it inside there. I'm going to pass a reference. I'm going to pass a reference. Ref is a keyword. I'm going to pass a reference. And what is the value of that reference? It is provider. The value of the reference is provider. So when this guy, the container or the factory class, when we return this instance of renderer, it will notice this line and it will call the setter method, pass the instance of the provider. Now it will have to instantiate the provider then, isn't it? Where it will happen? It will happen over here. Provider, provider. It will take this provider, link it to this provider over here, and you understand that, okay, this is the provider that has to be passed inside it. It will instantiate the HelloWorld message provider, right? And that provider is supplied over here as a reference inside the set message provider. The set message provider will set the message provider, and that instance renderer will be returned back. It might be a bit more to digest, I understand that, but think about it. Just imagine the scenario. I'm getting the renderer, the setter method will call. Okay, the ref is a keyword. The ref that says that, okay, there's something that I have to pass here. What is that something? That something is provided over here. And don't worry, we're not going to be working property files. It's just that migration we are having. Eventually, we'll move to an XML format. That is much cleaner and better to understand. But if you have to do something in a property file, this is what we'll have to do. Okay. So now what happens? Now what happens is that all I need to do is simply say, boss, give me the renderer, and I'll call the render method. I no longer have to deal with the aspect of instantiating the provider, setting the provider inside the renderer. All those deals are like written off. I don't need to do that anymore. Right? Correct? Isn't it? Does it make sense? Samajh raha hai? Kuch questions hai? All this thing that happens, that logic that says that, okay, this dot and setter method should call, all that stuff is defined in this method, register bean definitions. It's that logic is given in this method that understands that, okay, if this is the format, pass the provider inside the render and give it back. Are you getting it? How the dependency injection works over here? This is the real dependency injection. I'm injecting a dependency externally. I'm injecting a dependency externally by simply saying in a property file, or for that matter, in a XML file. The XML file would look something like this, wherein I would say bean ID. Now, whenever I say get property over there, get bean over there, okay, it will look for the ID over here. So renderer is something it will search for, right? What it would return? It would return the standard message renderer, the class attribute mentioned so. But if you notice, there's a body of the bean that has the property tag. That property tag says that there's a property called as message provider, there's a field called as message provider, okay, and a setter method will be called. A setter method will be called, and an instance will be provided. What is that instance? It's a ref. It's a local reference. What is the value of the reference? Provider. That means it will search for a bean ID with the ID provider. It will search for a bean which has the ID provider. It searches that ID provider, instantiate that provider over here, pass it to that setter method, right, and then return the renderer. This particular way of how we are injecting the bean is called as property injection. This is called as property injection. Why? Because we are injecting a property by calling the setter method. And now we'll make it more clean. Okay, there is a constructor called as class path XML application context. Okay, it's part of the string, or something that we have not made. We simply pass the XML file, and the rest is taken care over there. If you understand the logic, okay, read the XML file, create the factory for it, where there's a key value pair, all these things will be taken care over there. Whatever we did manually over here, in this previous example, okay, now all that logic is there inside this constructor, which is already created. We don't need to do anything. And we simply say new class path XML application context, we get the factory. On the factory I'm saying get bean renderer, the get bean renderer will search for a bean with the ID renderer, right, and then that will return me an instance of message renderer, and I'll call the renderer method. This is what dependency injection is all about. Getting it? And Spring has that intelligence to understand that, okay, this is the XML file, create the key value pair, create the dependency chain. That is something they can care over there. This is the example of the property injection. Is it clear? Any question? Sure? Amok, Vikram? Pakka, no questions? Okay. The way we saw an example of property injection, there is something called as constructor injection also. constructor injection, wherein the class, let's say I'm now injecting a class called as provider, which is configurable message provider, and I want a constructor to be executed that takes a value. Now here it's a bean, right? So it's going to be an instance. I can't hardcode that instance, so it has to be a ref. But in this case, it's a string value. So I can say a value tag over here. I can say a value. So this will basically call this constructor. Rather than calling the default constructor by instantiating, okay, it will call this particular constructor that takes an argument message. Makes sense? This area, this way of code, injecting is called as the constructor injection. This area that we saw, this is called as the property injection. Does it make sense? Are you guys with me? Same page? Just imagine the flow. We had this simple HelloWorld program, then we realized there are certain problems of decoupling over there. We started to decouple. We created separate classes. After creating separate classes, we realized that making one change in the renderer is going to affect my provider. Then we brought in interfaces so that it can become more generic. Then my provider, okay, then my renderer was intact. I just kept on changing the provider because the interface reference was there. But now the launcher got affected. Why? Because eventually I have to write that class name somewhere, right? So what we thought, let's take this approach to a property file, because I don't need to compile and run the property file. Right? Property file is just there's a text file. I mean, similar approach would be a database in that matter. After that, I thought let's make it more optimized. Decoupling is done. Okay, let's take a optimized approach over here. And I took in the way that whenever somebody is asking for the renderer, let's give them the provider, right? And we move to this area of how we supply the facility of injecting. We saw the example in a property file, and now we are seeing that example in a XML file. This is the fundamental way of how we carry ahead. Any questions? No? All clear? Property injection, constructor injection. This is dependency injection part. This is the AOP. Not AOP. IOC. Sorry, IOC. Inversion of control. Inversion of control. Later on, they gave this Mr. Martin Fowler. He is one of the designers. He mentioned it as the dependency injection. Initially, it was called as inversion of control. Moving further. Now we will talk of annotations. As you know what annotation is, right? What are annotations? @ override. Yes, an @ override. What that basically says to the compiler that this is an implementation, overridden implementation. That's the annotation. Annotation is applicable on the field level, on the method level, at the class level. So if it's on the class, the annotation applies on the class. So on the member of the field, it's applicable on the member. It's always on the top of something. If it's on the top of method, whatever is returning back it's applicable on that thing that is returned back. Okay. What we are going now, this is optimization. Okay, what are we going to optimize? The dependency injection part, which you mentioned in the XML file. I don't want to do that myself. I want to Spring understand that. I want to make it more super intelligent now. So let's see how it happens. Okay, first change. I don't need the setter method in this case. If I'm working with XML, yes, I need the setter method. But if I'm using annotations, I don't need the setter method. I can say @auto_wire. Which field do I want to inject? Message provider. So I say @auto_wire message provider over equal to null. Okay, right? Further change, I remove the property injection body over here. If you remember the previous example, inside the body of the render, I had written property, name equal to message provider, ref equal to provider. It's no longer there now. It's removed. Okay, and I just add a small tag called as context : annotation context. I just added one small thing. Okay. Now how does it work? Now when I say, okay, the rest of the code is same. Okay, that launcher, everything is same. Now when I say get bean factory.get bean renderer, initially what used to happen? Used to go to the XML file, search for the bean that has the ID renderer. The same thing will happen now. It will come here and search the XML file. Inside the XML file, you'll see there's a bean with the ID renderer. Correct? You'll see this is a renderer. It will start to instantiate this class. Fine. It will do that. It will start. And as you know, when a class is being instantiated, the members get a default values. If it's an integer, it gets 0. If it's a string, it's null. Right? It gets default values. So we'll do the same thing for these fields also. But when it comes across this field, message provider, okay, which is of type message provider capital M, it realizes there's an annotation. What is the annotation? @auto_wire. Now what does this say? There's a convention. What is the convention? Now hear me properly. The convention is get one concrete implementation. You know what a concrete is, right? Or something we can do new. Get one concrete implementation of the type of the member. What is the member over here? Message provider with a small m. What is the type of the member? Message provider with the capital M. So the type is message provider with the capital M. So it needs to go search for one concrete implementation of the type. In this case, message provider. Where will it search? It will search inside the XML file. It will search inside the XML file. Inside the XML file, it will go and search for one concrete implementation of the type message provider. Right? So it will scan. It will see, okay, renderer. Is this a type of message provider? Standard message renderer? Nope, it doesn't, because it has nothing to do with the provider interface or anything whatsoever. Chuck it. Moving ahead. Provider. Is this a type of message provider? Yes, it is, right? Because it extends the message, it implements the message provider interface. So HelloWorld message provider will be instantiated and supplied to this reference. So the instance of HelloWorld message provider will be created on the heap, and this reference will point to it. What was the convention? The convention was go find only one concrete implementation of the type. It can be the same class also. I could have simply given message provider. I could have hard-coded over here HelloWorld message provider. That also would have fulfilled the requirement because it's the same thing. So find one concrete implementation of the type. That is the convention. So we are applying a convention over here. And on the basis of that convention, the field will be injected over it. And it will be populated. Is this clear? How added auto-wired works? What are the changes? Changes are, first I need to place the added auto-wire on the field on which I want this injection to happen. And in addition to that, I have to say context colon annotation config. This is because of which the auto-wiring works. Any questions?
Can you once again tell me how the identification takes place?
Okay, I'll repeat. So I say factory.getBean renderer. It sees there is a bean called as render over there. Standard.message render. It will start to instantiate it because when it instantiates, the default fields get default values. The fields will get default values. Same thing will happen with message provider. It does that, but at that time it realizes there's other auto-wired, and as you know, annotation when it's played on the field will undergo that process. So at that auto-wired means this field will be auto-wired. Auto-wiring happens with the convention. What is the convention? Go find one concrete implementation of their type. The field is what? Message provider with a small m. What is the type? Message provider with a capital M. Right? Go search one concrete implementation of the type message provider. Where does it search? It searches in the XML file, the beans.xml file. Okay. There it will try to understand, to see bean by bean. Okay, this is a bean renderer, standard message renderer. It will look into the definition and see, is this class a concrete implementation of message provider? It is not, because it does not implement the message provider interface. Moving ahead, provider, HelloWorld message provider, it sees in this definition, is this a concrete implementation of the type message provider? Yes. Why? Because this class implements the message provider interface. Doesn't it? Yeah, it does, right? Fulfilling that requirement, it will instantiate it, create it on the heap, and that reference will be given to this bean over. That is my Spring Factory's job, how it will link it. Something I don't need to worry about. But the convention is something I have to be aware.
So the identification goes
by
as
type.
per the data type.
Type, exactly. Prior to 3.0, these are coming 3.0. It was there were 4 types: auto wiring by type, which will be applicable now also if you want. By type, by name, by constructor, and auto means mixture of all the 3. But that was very confusing. It was so confusing that people eventually moved to a straightforward approach. Just give me by type. Otherwise, we had all these 4 types of auto wiring. Is it clear till here? Auto wire. We are slowly moving from the configuration to the convention. Is this part clear? Any questions? Vikram, Amok, guys? If you have any doubt, please let me know. If I'm fast, let me know if I'm going too fast, if I'm going too slow, for that matter. Okay? Now the next improvement that I want to make is, why do we even have to declare all the beans in the XML file? And if it's so smart to get the injection, isn't it just so smarter to just go and read the packages, right? So we go to another annotation. We now talk about an annotation called as component scan, @component. What are the changes? First change is, okay, now as I am not going to declare the beans, I need to declare at least the location right, where it will search. So that thing is given through this tag called as context colon component scan, and there's an attribute called as base package, and I supply the package name. So I'm basically saying the Spring Factory or the Spring container that whenever you want to go search the beans, go and search inside this package. And since I'm using component scan, I don't need to use annotation config. That thing will be taken care by component scan also. Okay, that's one change. Further, in order for the class to be eligible for scan, it needs to have component or any subtype. Component is like a mother pair. It's like a mother annotation. Okay. Beyond component, we have controller, service, repository. There are subtypes of component. Okay, we'll see them in the MVC scenario. But for a class to be renderable, okay, for scanning, eligible for scanning, we have to declare this connotation on the top of the class. Okay, so let's imagine the scenario. I say factory.getBean renderer. My launcher is still there, same thing, no changes over there. It comes to the XML file and tries to search for a bean with the ID renderer, right? When it searches, it sees that there's component scan. It's not going to get that bean over here. It's going to go inside the package. It will search. First, is this class eligible for scan? Forget the purpose why you came here. But is this class eligible for scan? What is it? It is component. Yes, it is eligible for scan. One thing is concluded. What is the purpose? What was the intention of coming here? You wanted a bean with the ID renderer. That is fulfilled by this text over here. You put the renderer inside component annotation, right? And that is like an ID. Or if not that, you can give value equal to renderer. It is same thing as writing the bean ID equal to renderer. This is how it comes to about this identification. Is this part clear of how it is getting the bean? Component scan. Component scan means what? First declare the package from where we're going to search, because I'm not declaring the beans in the XML file now. And then on the classes I have to mention the annotation for its eligibility. No matter what purpose you have come for, in auto wiring or getting the bean, whatever. But if you want to work for component scan, you need to have added component over here. Right? Second, the purpose. What I came here for, I wanted a bean with the ID renderer. That is fulfilled by this text over here. Renderer. Or you can say value equal to renderer. Because they can have many attributes. Value is just one of the attributes. If you are going to have many attributes, writing like this will not work. Just double quote renderers. We'll have to write value equal to renderer. Clear till here? Okay. Now, if you think about it, auto wiring. What's going to happen in auto wiring? Because the beans are not there now, right? So let's understand that. So eligibility scan completed, and yes, this is the class. This is the renderer, right? It will instantiate. As you're instantiating, the default members get null values, whatever default values. Message provider will come across and say, it's auto wired. What is auto wiring? Go find one concrete implementation of the type. What is the member? Message provider. What is the type? Message provider with a capital M. Where will it search? XML file. But boom, no beans. So what it does? It understands, there's a component scan. The beans will be searched in this package. So it will search the package. It will come here. First, is this class eligible for scan? Added component? Yes, it's eligible for scan. Scanning part is complete. Purpose? I want one concrete implementation of the type. Is this a concrete implementation type of message provider? It's not. There's a renderer over here. It does not implement the message provider. That's the logic, right? So it will check this class. Moving ahead. First, is this class eligible for scan? Yes, we have added component on that. Second, does this fulfill the purpose of concrete implementation of the type? What is the type? Message provider with small m. What is the actual type? Message provider capital M. So it does implement the message provider. Hence, it is a concrete. It's a class. The concrete implementation of the type. Requirement fulfilled. This thing will be instantiated, and this will be linked to this member over here. So the only thing is that the location has changed, but the work is the same thing. Right? That's how component scan uses my auto wiring. Any questions? Now we are seeing component, and we are going to go in detail. So another 5-10 minutes. I'm done. That's fine. No, I don't need this. I'm just going to wrap up. Okay. So this is annotations. This is just a sample. You're going to explore further how auto wiring works, what different levels does it work, what is added component, what things we can experiment with added component. Any questions?
So the two classes should be in the same
Package. Yes. If you want it to be searched. This is called as the convention approach. We have completely moved to the convention side now. Initially that we saw the beans being declared in the XML file, that was the configuration. And as per the standards in industry now, if you notice, mostly development happens inside the convention aspect, rather configuration. They prefer to move to a convention partner. So most of the examples in implementation also will be from that aspect. Is it clear? Any questions? Okay. Let me stop this guy.